Good day, students, and welcome to part one of the STAAR 2013 release questions for Algebra 1. We're going to be going over questions 1 to 5 in this installment. For other parts of this installment, just go to math.serve.com and look under the test prep section, and you should be able to find the subsequent parts, or just simply subscribe for the next parts to this review series. Alright, let's take a look at question number 1. It says, a dentist made the scatter plot below to show the number of cavities her patients had as it relates to the number of times they flossed their teeth each week. So we have number of cavities graphed along the number of times the patient flossed each week. So the question is, which of the following describes the correlation for the data? Is it positive, nonlinear, negative, or no correlation? So what does positive correlation look like? Positive correlation is when the points basically follow an upward pattern. Okay, from left to right, the points basically gather themselves in an upward pattern like this. So you see these points I'm drawing? From left to right, the points are increasing, so that's a positive correlation. If you wanted to represent the data with a line, you have a line going up from left to right. Okay, that's increasing or positive slope. Okay, so that's an example of positive correlation. Points going up from left to right. Nonlinear correlation could be a correlation that follows the pattern of a curve. For example, we have the points going up, and then all of a sudden the points start to go down, and then the data points start to go up again. Okay, so if you wanted to describe this pattern, what kind of curve could you use to describe it? Can you use a straight line like the first example? Absolutely not. In this case, you're going to have a curve. Okay, so this is not a linear correlation, it's a nonlinear correlation. If it's not a line, if you can use a line to describe the pattern, then it's nonlinear. Okay? Alright, so we have linear positive, which is increasing from left to right. Nonlinear, which is like a curve of any nature. Negative correlation is what you get when it's decreasing. The opposite of positive is negative. So negative is basically the set data points that you plot are falling down. They're following the pattern that goes down from left to right. Okay, something like this. You just have data points that go down from left to right. And if you wanted to model the line of best fit, the line will have a negative slope, or it will be going down from left to right. Okay, so that's an example of negative correlation, the data points going down. No correlation basically involves a situation where you can't really model the data with a line of any sort, or even a curve. Okay, so if you just have dots all over the place, like this. So in most cases, if you draw the line and if you draw a line and the line is simply horizontal, that's no correlation. It's neither positive nor negative. It's just all over the place without any unique pattern. Okay, so no correlation is somewhere between positive and negative. Is either positive, negative, no correlation, or nonlinear represents some kind of curve pattern in the orientation of the points. All right, so let's look at this situation right here. If you look at the overall behavior of this line, will you say it's decreasing, increasing? Will you say it's curved, or will you say it has no, it's neither of them, basically a horizontal pattern? So if you look at this, what you want to do to help you visualize the situation is you can just group them. Let's group them like this. So look at that grouping. So grouping them like this, what is the overall pattern that we have here? If you look at this shape I just drew, it's decreasing from left to right. So since it's decreasing from left to right, this is an example of a negative correlation. So that's a possible line fit right here. Um, so this is a negative correlation here, negative correlation. Why is it a negative correlation again? Because this line is going down from left to right, or the line of best fit has a negative slope, or the overall pattern is it's decreasing. Okay, and that's consistent with option letter C. All right, let's take a look at question 2. We're asked to ask what is the vertex of the quadratic f of x equals x squared plus 6x plus 10. So we're going to find this using the formula. The vertex equals negative b over 2a, comma, f of negative b over 2a. Okay? So this is basically the x-coordinate of your vertex, and this entire expression right here is the y-coordinate of your vertex. Okay? So since the y-coordinate is dependent on the x-coordinate, we have to find the x-coordinate first. All right? So where f of x, the function, is equal to ax squared plus bx plus c. Okay, the quadratic has to be in standard form. All right, so let's go ahead and write down our function. F of x is equal to x squared plus 6x plus 10. We can see that the vertex is only dependent on a and b. So what is a and b here? A is the coefficient of the x squared, and b is the coefficient of the x, okay? So there's no number there. We can put in the invisible number, which is 1. So that would be our a, and b is 6, all right? So this setup implies that a has a value of 1, and b has a value of 6. All right, so what are we going to find first, the x vertex or the y vertex? We're going to find the x vertex first, since the y vertex is dependent upon it, all right? So x-coordinate of the vertex, let's call it x sub b, is equal to negative b over 2a. So we're going to plug in the values. Negative b is 6 divided by 2a, 2 times 1, since a is 1. We have negative 6 over 2, which is equal to negative 3. So this is the x-coordinate of a vertex. With that in mind, we can eliminate options J and F. Now let's see which one is the correct answer. Now how do we find the y-coordinate of our vertex? The y-coordinate of a vertex, per this formula right here, is f of negative b over 2a. Alright, so what on earth does this expression mean? It simply means you plug in the x-coordinate of the vertex, which is negative 3, into your original function, f of x, right here. Okay, so let's go ahead and evaluate that. F of negative 3 is equal to the original function evaluated at x equals 3. So instead of x squared plus 6x plus 10, we're going to have negative 3 squared plus 6 times negative 3 plus 10. How did we get this? We simply replaced all the x's with the new input value, which is negative 3. Now let's simplify this expression using order of operations. Please excuse my dear Aunt Sally. Take care of the powers and multiplication first. So powers first, negative 3 squared. Now remember, negative times negative is positive, so this becomes positive 9. Positive times a negative is negative minus 18 plus 10. Okay, let's simplify this further. We have 9 minus 18 is negative 9. Negative 9 plus 10 is equal to positive 1. Okay, so what is our vertex going to be? Our vertex is now going to be negative b over 2a, which is negative 3, comma, f of negative b over 2a, which is f of negative 3, function evaluated at negative 3, result is positive 1. Okay, so our answer is option letter H. All right, let's take a look at question number 3. It says, which of the following graphs best represents a system of equations that has no solution? So what does it mean for a system represented graphically to have no solution? It has no solution if the two lines never intersect. So no solution basically means that the two lines never intersect. Now what does it mean for two distinct lines to never intersect? Well, that basically means that they're parallel. Okay? So what does it mean for two lines to be parallel? It means that the slopes are equal. Okay, so that's equal slopes. So if we look at these lines, let's call them 1, 2, 1, 2, 1, 2, and 1, 2 down here. Any pair of lines that are parallel, those are the lines that satisfy this equation. Those lines will have no solution because they remain parallel forever and they will never intersect. Alright, so let's see. We can clearly see that option B, there's an intersection here. There clearly is a solution between negative 4.5 and 4. That's a solution. So we eliminate that. That's not applicable. Now let's look at option A. Are these two lines parallel? Do they have the same slope? That's the question. So how do we determine that? What we do is we're going to pick two points that fall on the grid and on the line. So that's a nice point right there. It falls on the grid, the intersection of the grids and on the line. So here also. So that these two nice points can help me determine the slope of this line. We have a negative rise of -1 and a run of 2. So the slope of line 1 is equal to rise over run, which is -1 over 2. -1/2 is the slope of line 1. How about the slope of line 2? We pick two nice points again. So this is one nice point. A nice point falls on the intersection of the grids and the line. And then there goes another point right here, which falls on the intersection of the grids and the line. Now what is the slope here? We have a negative rise of -2 because you count 1, 2, and a positive run of 3. So the slope of line 2 is rise -2 over run 3. Are these two values equal? The answer is no. So since M1 is not equal to M2, that means that M1 is not parallel. So M1 is not parallel to M2. So what does it mean if they're not parallel? That means there's somewhere, at some point, they will definitely intersect. Okay? Alright, let's look at this one. This one we can clearly see that the slopes are different. They almost intersect in here. We can clearly see that. So this is not a viable answer right there. So we can eliminate A, B, C. Final answer is D. So this should be our answer. Okay? Well, to make sure that our answer is correct, let's go ahead and find the slope of these two lines. Their slopes must be equal, which will indicate that they're parallel. And since they're distinct, they will never intersect. So to find the slope, we pick two nice points that fall on the intersection of the grids and the lines. So this is one nice point here. And let's see, we need another nice point. Oh, right here, that's another nice point. Okay, so our rise, this would be our rise. Change the color. Our rise of our rise is going to be a fall. Our rise is going to be -3. So we have a -3 rise. And our run is going to be 1, 2, 3, 4, 5, 6, 7. +7. So the slope of line 1 is going to be the rise, -3, over 7, the run. Now let's take a look at this line. We want to pick two nice points again that fall on the intersection of the grids, and where that happens, you have the line intersecting the point. So this is another nice point right here. Let's see if we can find another nice point that will work. We have another nice point right right here. Okay, so let's see what the slope is in this case. So we're going to go down to here to the line that's to a point that falls on the horizontal line with this sort of point right here. So that's 1, 2, 3, a run of -3. I mean a fall, a negative rise of -3, and a run of 7. Alright, so now what's the slope of the second line? The slope of the second line is -3 over 7. Now since the slope of the first line is equal to the slope of the second line, that means that this line 1, that means that line 1, L1 is parallel. L1 is parallel to L2. The two lines are parallel. Okay, so if the two lines are parallel, that means they never intersect, and that means that there's no solution in this case. All right, so that's that. And let's go back to this option A right here. I was supposed to say that line 1 is not parallel. That slope 1 is not parallel. So here line 1 is not parallel to line 2 because their slopes are not identical. All right, let's take a look at question number 4. It says a family will travel 350 miles from their house in order to reach Dallas, Texas. Which inequality can be used to find all possible values of t? The time it will take this family to reach Dallas in hours if they travel at an average speed of at least r miles per hour. All right, so this is kind of like a physics problem. This problem is relating distance. Let's call that d. Time. Okay, let's call that t, and speed. All right, we can call that r. Okay, r miles per hour. So do you remember the formula that relates distance, time, and rate, or distance, time, and speed? It is the DIRT formula. Distance equals rate times time. It's the DIRT formula. Okay. All right. So with this formula, we're going to be setting up an inequality in this case. As you can see, the different options we have here. The key inequality that's gonna, or the key word that's gonna help us determine our inequality is the word least. Okay. So the speed is at least r miles per hour. So if the speed is at least r miles per hour, that means that the speed can be r miles per hour or greater. Okay, so speed is going to be greater than or equal to r miles per hour. Okay, so we have this equation, distance is equal to rate times time. So given that condition of r, if we apply it here, what we're going to have is that the distance is going to be greater than or equal to the rate times the time. Okay, since the distance has a lower bound based on the speed, so if this is the minimum speed, if the speed were r, then our distance would be rt. But since this can be bigger, as this goes bigger, guess what? You cover more distance, because the faster you drive, the more distance you cover if you keep the time fixed. So instead of distance equal rate times time, since the rate has a minimum value or higher, the distance is going to have a minimum value or higher, because the distance is at least this rate times time. Okay, so this is the inequality that we're going to be solving here. So we know that the distance is 350, and that's going to be greater than or equal to the rate r times the time t. Okay, now in this situation the distance is fixed, so the faster you go, guess what? The shorter the time is going to take you to get to your destination, since the distance 350 is fixed. So in order to finish this off, we're going to solve this inequality for the time t. So to accomplish that, we'll just basically divide both sides by r, divide by r, divide by r. These two divide out, and then we're going to have t is less than or equal to 350 over r. Okay? Now note what happened here. You see this inequality? Think of it as an alligator is eating this expression right here, right? It always eats the bigger meal. So if I switch it around, if I put the t first, the alligator mouth is still going to be facing 350 over r. So I just basically used the symmetric property of inequalities. I switch this around, and then since I switched these, I have to switch the inequality to this orientation right here. Okay, so our answer is going to be option letter H. All right, so let's take a look at the last one, number 5. This basically assesses our understanding of what the word slope means. It says the graph below shows the relationship between the number of dollars a worker earns and the number of hours worked. What does the slope of the graph represent? So let's label our axis. So this is going up and down. This is known as our rise. Okay? And this is our run right here. Remember, slope is equal to rise over run. So this also applies to the unit. Okay? So you can think about over as per. Okay, so we can call it rise per run. All right, so let's look at this situation here. What is our rise? Our rise is, so our slope is basically looking at our slope is going to represent our rise, which is amount earned, over is per. Now what is our run? Is time worked. Okay, time worked. So that's basically what our slope represents. So let's look at the options we have here and then see which one is consistent. So number 1, number of hours worked. It takes to earn 320. That doesn't align with this description here. This is amount of money earned, rise, per, divided by hour. What is hour? Time. So this is exactly what we're looking for. Okay, so this amount of money earned is our rise, per is divide, hour is the time worked. Okay, this says amount of money earned for 40 hours of work. This is a point. 40 hours of work, you earn $320. That's not the slope. That's evaluating the function at a particular time. Okay, and then this one says number of hours worked per dollar earned. This is the reciprocal. That's totally wrong. Okay, so remember it's rise over run. The measure on the y divided by the measure on the x is the significance or the unit of our slope. All right, so our answer is option letter B. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel so you can get updates to the next part of this review installment. More clips can be found on math.serve.com, and do post the comments to let us know what you think about this presentation. We really appreciate it. Thanks again for watching, and have a wonderful day.